All right, we've got a really interesting mix of stuff about the web for this deep dive.
Yeah. Definitely.
We're talking like the real basic stuff, like HTTP, all the way to actually building a web crawler with JavaScript.
Very cool.
We're going to be looking at some YouTube videos.
Okay.
From freecodecamp.org, Dave's Garage.
Love Dave's Garage.
And Hackersploit. So get ready to like really see the internet in a way you've never seen it before.
Absolutely. I think what's so fascinating about the web is, we use it every day, but we don't really think about how all this stuff works.
Right?
Like when you're sharing photos online, streaming videos, sending messages.
Yeah.
It's all thanks to this thing called HTTP.
Hypertext Transfer Protocol.
Exactly.
Okay. It's funny you mentioned that because, like, I was just thinking about the other day, like, way back in the day when, like, you had to email photos as attachments.
Oh, yeah.
And it would take, like, forever.
Forever.
And now it's just, like, boom, instant. Right.
Yeah, that's HTTP. It makes all that possible.
So it's like the language that makes all this internet magic happen.
It is. It's like a set of rules that computers use to talk to each other over the internet.
Okay.
And it all boils down to this thing called the request-response cycle.
The request-response. Okay. Can you break that down a little bit more for me?
Yeah, so imagine you're using the YouTube app on your phone.
Okay.
And you want to watch a video. Your phone, which is the client, sends a request to YouTube's servers, which is somewhere out there, saying, hey, I want to watch this video.
Right.
The server then processes that request and sends back the video data as a response.
Okay.
That's how you actually see the video on your screen.
Ah, okay. So like almost like I'm ordering takeout.
Yes.
I'm the client. I place my order.
Exactly.
The restaurant is the server, cooks it up. And the delivery driver brings me the response, which is hopefully a delicious meal.
It's the same concept, yeah.
Got it. So is that why like there's all this talk about front end and back end?
Yeah, absolutely. Just like restaurants have different areas, like the kitchen, dining room, websites have these distinct parts too.
Okay.
Like the front end is what you see and interact with in the YouTube app.
So like all the buttons, the videos, comments, that's all the front end.
Exactly, yeah.
Okay, and then the back end is like all the behind the scenes magic.
It is. It's all the servers, the databases, all the complex infrastructure.
Okay.
It's storing those videos, comments, user data, everything.
So that front end app on my phone is constantly like talking to the back end?
Yes, it's constantly sending requests.
Okay.
And the back end is sending back responses.
Got it. It's a constant conversation.
Yeah, pretty much.
That's so cool. One of the videos I mentioned, like YouTube doesn't actually store like every video on my phone, right?
Right.
Which makes sense. But how does my phone know where to find like the right video on YouTube's servers?
Yeah, that's a great question. That's where URLs, domains, and ports come in. It's like the internet's address system.
Okay.
So every device online has this unique IP address.
Okay.
It's like a phone number, but for your computer.
Right. So it's like a way to identify it.
Yeah.
Yeah.
But IP addresses, they're just a bunch of numbers.
They're really hard to remember.
Very hard to remember.
Like I can barely remember my own phone number half the time.
Right. So that's why we use domain names like google.com, which are much easier to remember.
That's way easier. Okay. So, but how does like my phone know which IP address goes with google.com?
That's where this thing called DNS comes in.
DNS?
The domain name system.
Okay.
It's basically a massive phone book, but for the internet.
Okay.
It translates those human-readable domain names into the actual numerical IP addresses.
Okay.
One of the videos, Dave's Garage, he uses that same phone book analogy, which is really helpful, I think.
Yeah, it's a good analogy.
So when you type google.com into your browser, your computer asks a DNS server, hey, what's the IP address for this domain?
Okay.
And the DNS server looks it up in its giant directory and says, okay, here's where you need to go.
That's really clever. I never realized there was this whole like lookup process happening in the background.
Yeah, a lot going on behind the scenes.
Okay, so we have the right IP address now.
Right.
But the freecodecamp.org video also mentioned ports.
Oh, yeah, ports.
What are those all about?
So ports allow multiple applications to run on a single server.
Okay.
It's kind of like a building with a bunch of apartments.
Okay.
They all share the same street address.
Right.
But you specify which apartment you're going to by using the apartment number.
Got it.
In this case, the server is the building,
Mm-hmm.
and the applications are like the apartments.
So like one server could be hosting a website on one port and then like a database on another port?
Exactly. And each port has a specific number.
Okay.
There are actually over 65,000 ports available.
What?
So a single server can do a whole lot.
Wow, that's a lot of apartments.
It is.
That's crazy. Okay, so we've sent our request to the right address, IP address, domain name,
Got the port number.
the specific port. What happens next?
So that's where HTTP methods come in.
HTTP methods.
These methods, they tell the server what kind of action you actually want to perform.
Okay.
Like, are you trying to view a page, submit some data, delete something?
So, like, it's not just sending a message. It's like saying what you want to do with that message.
Precisely.
Got it.
So the most common method is GET.
Key.
You use that to retrieve information.
Okay.
Like when you're viewing a web page or downloading a file.
Okay, GET, that makes sense. But the freecodecamp.org video mentioned other methods too,
Right.
like post, PT, and delete.
Yeah.
What are those all about?
So those are used for interacting with the server in different ways. Think of them like verbs.
Okay.
So GET is like read.
Okay.
POT is more like create.
Okay.
You use PAT to send data to the server.
So it's like sending a letter instead of reading one. Okay.
Like when you're submitting a form or uploading a file.
So different methods for different actions.
Exactly.
What about POT and delete? I feel like those are kind of self-explanatory.
Yeah, you got it.
Okay.
PUT is used to update existing resources on the server.
Right.
Delete, like the name suggests, it's for removing something.
Makes sense. It's
Yeah.
like a whole set of verbs for talking to a web server.
It's a great way to put it.
This is getting really interesting. And the hackersploit video, they mentioned something called the options S method,
Oh, yeah?
and they said it was important for penetration testing.
It is.
What's that all about?
So the options method, it's basically used to figure out which HTTP methods are allowed for a specific resource.
Okay.
So it's super valuable for security researchers, ethical hackers, pen testers, anyone who's, testing a web application security.
So it's like checking if a door's locked before trying to get in.
Exactly. It's a great analogy. Yeah, it helps them figure out if there are any vulnerabilities.
Please.
It's all about responsible disclosure and making the web a safer place.
Okay, so like if I was building a web application, how would I know which methods to use?
That's where API documentation comes in.
API documentation.
So APIs are like sets of instructions that tell you how to interact with a specific web service.
Right.
Every good API will have documentation.
Got it.
And it tells you exactly which methods are supported and how to use them.
So just like reading the instructions before putting together like a piece of furniture.
Exactly. Yeah, you definitely need those instructions.
I definitely need those instructions. This is making me realize like how much is actually happening every time I click a link or submit a form online.
Yeah, there's so much going on.
It's like a whole hidden world.
It is. And we've only just scratched the surface.
Oh, no.
There's so much more. We haven't even talked about headers, data formats, security considerations. It's all fascinating stuff. It really affects how the web works at a fundamental level.
Well, let's dive into those next. I'm ready to learn more.
Let's do it. You know how we were saying earlier that HTTP is like a language computers use to talk to each other?
Yeah, like the language of the web.
Well, headers are like adding those subtle cues and gestures you use in a conversation.
Okay. Like body language.
It's more like adding extra information and context to those messages.
So it's not part of like the main message itself.
Right. It's like extra bits of information.
Okay.
They can tell the server things like what browser you're using, what operating system you have, or even your preferred language. You can even tell the server what kind of data is being sent over.
So is it kind of like labeling a package?
Yes.
So the person receiving it knows what's inside before they open it.
That's a great way to think about it. And just like with those packages, having the right label is super important for everything to run smoothly online.
That makes sense. So what about data formats? You mentioned JSON, which seems to be really popular these days.
Yeah, it's everywhere.
What's so special about that?
So JSON stands for JavaScript Object Notation.
Okay.
It's basically a way to represent data that's both lightweight and easy to read. It's like a well-organized list with keys and values, so humans can understand it and computers can process it really easily.
So it's like a digital filing cabinet where everything is labeled and in its place.
I like that analogy. And often JSON is preferred over other formats like XML.
Okay.
Because it's much more concise and easier to work with.
So it's all about efficiency.
Efficiency is key.
Okay, so let's say I'm on a website and I'm waiting for something to load.
Okay.
Like an image or a video. What's actually going on behind the scenes?
That's where this concept called asynchronous programming comes in.
Asynchronous programming.
So this basically allows your web browser to do a bunch of things at once.
Okay.
Like it can download images, fetch data, all without making you wait for each task to finish individually.
Right, because I'd hate to have to like wait for each image to load
It would be awful.
before I could do anything else on a web page.
Yeah.
That'd be so tedious.
It would be a terrible user experience. So think of it kind of like a well-coordinated kitchen.
Okay.
You have multiple chefs all working on different dishes simultaneously, but the meal comes together smoothly.
Okay, so asynchronous programming is like a well-oiled machine.
Exactly, yeah.
But how do web developers actually manage all of these different operations?
Yeah, so a really common way to do this is with promises.
Promises.
So a promise, it basically represents the eventual outcome of an asynchronous operation.
Okay, I think I'm following. So it's like making a promise to a friend.
Exactly.
Okay.
Let's say you promise your friend you'll bake them a cake.
Okay, I like cake.
There are two possibilities.
Yeah.
Either you fulfill your promise and you bake that delicious cake.
Yes.
Or something happens and you can't.
Like the oven breaks or I run out of sugar.
Yeah, exactly.
Like, oh,
So in programming, if the operation is successful, the promise is fulfilled. If not, the promise is rejected.
Okay.
So the browser could be like, hey, I promised to load this image.
Yeah.
And then it can go off and do other things while it waits for the image to download.
And then once that image is ready, boom.
Promise
fulfilled. Got it. That's how a browser can keep things moving.
Yeah.
While also dealing with like all these different tasks.
Multitasking at its finest.
This is starting to make so much sense now.
Good.
But with all this information flying around the internet, how do we keep it secure?
Right.
How do we make sure no one's eavesdropping on our digital conversations?
That's a great question.
Yeah.
That's where HTTPS and encryption come in.
Okay.
Remember earlier when we were talking about HTTP being like having a conversation?
Yeah.
Well, plain HTTP is like having that conversation in a crowded room where anyone can listen in.
Okay.
HTTPS, on the other hand, it's like having a private conversation.
Right.
Where only you and the person you're talking to can understand what's being said.
So HTTPS is like whispering secrets.
It's even better than whispering. It uses really strong cryptography to scramble the data.
Yep.
Making it practically impossible for anyone to snoop and understand what's being transmitted.
That's good to hear. How does that encryption actually work?
So it's all based on using fancy mathematical algorithms and keys to basically transform that data into an unreadable format. One of the videos we watched used a great analogy. They talked about exchanging keys to encrypt and decrypt messages, like a secret code.
So it's like having a secret language that only the sender and receiver can understand.
That's exactly what it's like.
Wow, that's cool.
And this type of encryption is essential, especially when we're talking about protecting sensitive information like passwords, credit card numbers, all the important stuff.
Makes sense. Keep it all private. So whenever I see that little padlock icon next to a URL, that means the connection is secure.
That's right.
Encrypted with HTTPS.
Exactly.
So I can browse with confidence.
You can rest assured that your information is protected. It's always a good habit to look for that padlock icon, especially when dealing with sensitive information.
Got it. So moving on to web crawlers. Now that we've talked about security, it makes me wonder, are there ethical considerations when building these things?
Absolutely. You bring up a really important point. One of the videos, the one from freecodecamp.org, talked about respecting a website's robots.txt file.
Robots.txt.
It basically tells web crawlers which parts of a website they're allowed to visit.
So it's kind of like knocking on someone's door before you barge in.
I love that analogy, yes. You don't want to overload a server with too many requests or try to access information that's not meant to be public. It's all about building responsible and ethical crawlers.
So there's a lot more to building a web crawler than just blindly following links.
Absolutely. It's a combination of both technical skill and also being mindful of how these tools impact the websites they visit.
Right, being a good internet citizen.
Exactly.
This has been an incredible journey. I'm starting to see the web in a whole new light. It's so much more than what you see on the surface. There's this whole fascinating world of communication happening behind the scenes, all thanks to HTTP and the amazing people who built and continue to develop this technology.
I'm glad to hear you're finding this deep dive so insightful. Knowledge is power, and understanding how the web works empowers you to use it more effectively and responsibly.
Absolutely. Speaking of using it effectively, let's talk about how all this comes together when you actually build a web crawler.
Yeah.
I'm ready to get into the practical side of things.
Let's do it.
All right, so we've talked about all the pieces like HTTP, requests, responses, JSON, even how to be ethical about it.
Right.
Now I'm excited to actually see like how to build a web crawler, how it all fits together.
Yeah, absolutely. So the freecodecamp.org video actually goes through a basic web crawler project using JavaScript.
Okay.
It's a great example of how you actually use these concepts in like a real world scenario.
Cool. So where do we even begin with something like that?
So the first thing you need is like a starting point.
Okay.
A URL, this is kind of like the seed for your crawler.
The seed, okay.
It's the first page the crawler is going to visit.
So it's like planting a seed that then grows into this whole network of like interconnected pages.
Yeah, it is a great analogy, yeah.
Okay.
So then what you do is use something called the fetch API in JavaScript.
Okay.
This lets you actually retrieve the HTML content of that starting page.
So we're just like grabbing the source code?
Exactly, like we were doing earlier to kind of like peek behind the scenes of a website.
Right, right. Okay. So we've got the HTML, now what?
So now what you need to do is extract all the links from that page.
Okay.
So remember how we talked about links being defined by a tag
Right.
with the href attribute?
Yes, the href, those are like signposts pointing to other pages.
Yeah, exactly. So you parse the HTML, which basically means you're analyzing it.
Okay.
And you're pulling out all those links.
So now we have a list of links. What do we do with those?
So then you add those links to a queue.
A queue?
Think of it as a to-do list for your crawler.
Oh.
It tells the crawler which pages to visit next.
So the crawler starts with that seed page, gets all the links, adds them to the queue, and then it just like keeps going through that list.
Yeah. Visiting each page, grabbing more links, adding them back to the queue.
Wow. It's like an automated explorer, like systematically mapping out the web.
It is. It is. And as the crawler keeps going, it can actually start to, like, understand the structure of the website.
Oh, wow.
Like which pages are linked to, which other pages, what kind of content is on each page, all sorts of things.
This is making me think of those, like, old maps where, like, explorers would, like, chart new territories. It's like the crawler is like an explorer charting the digital landscape.
I love that analogy.
Mm-hmm.
And just like those explorers, they had to be prepared for, like, unexpected challenges.
Right.
Our web crawlers need what's called error handling.
Error handling, right. Because things don't always go smoothly on the web.
Never. Yeah, exactly.
You might encounter, like, broken links, pages that take forever to load.
Yep.
Maybe even websites that try to, like, block crawlers.
Right. And that's where those ethical considerations come back in.
Right, right. So good error handling is, like, part of being responsible?
It is. It is. It's all about making sure your crawler behaves well.
Right.
And isn't causing any problems for the websites it's visiting.
Like being a good guest. You don't want to overstay your welcome.
Exactly. Or accidentally break something.
Right, exactly. We've gone from, like, understanding the basic language of the web to, like, building a tool that can explore it.
Yeah. It's been a journey.
This has been an awesome deep dive.
It really has. And I think it shows how, like, all these seemingly separate concepts are actually really interconnected. Understanding one helps you understand all the others.
I totally agree. So for our listener out there, like, what would you say is, like, the biggest takeaway from all this?
You know, I think the biggest takeaway is that, like, the web is so much more than what you see on the surface. There's this whole world of communication happening behind the scenes, all thanks to HTTP and the amazing people who built and continue to develop this technology. And honestly, anyone can start to unlock the secrets of the web. It just takes a little curiosity and some effort.
Couldn't have said it better myself. This has definitely made me even more curious. Imagine what you could build knowing all this.
Oh, yeah.
Like custom APIs, tools to analyze websites, even your own search engine.
Absolutely. The possibilities are endless.
I want to give a huge thank you to our expert for, like, sharing their knowledge and insights with us today. It's been so fun exploring the web with you.
It's been a pleasure.
And if you, dear listener, are eager to, keep learning and maybe even, like, start your own web dev journey, I highly recommend checking out our expert's work. You can find links in the show notes. And to you, our listener, thank you for joining us on this deep dive. Keep exploring, keep learning, and never lose that spark of curiosity. Until next time.